right, ladies, gentlemen, we are learning about long division today. I had to warm up. Hang on. Yeah, my usual, start the recording and then figure out what I'm doing. We're going to start with that, actually. Okay, so this is what we're going to start with. You don't have these, so just help me through this. How? Ooh. Turn the sound off. Yes, we need to remember this whole process, okay? So, hang on. 6 doesn't go into 2, so we don't write anything here. But it goes into 29 4 times, so we write it above there. 6 times 24, or 6 times 4 is 24. Wait. So we thought about how many times it would go in, and then we do multiply, right? And now we're doing subtraction, yes. Trying to keep track of what we're doing here because it's going to apply to the algebra. Okay, 6 goes into 53. Okay. So then we did how many times does it go in again, and then we're going to multiply and subtract. Okay, and we're not going to keep going. Yeah, bring down is a step as well. You're right. We should be talking about that. But I want to talk about how you would check this and or write it as an answer. There's several ways. When you were first learning this, you wrote 48 remainder 5, right? Okay. Oh, there's no decimal. Yeah, that's my scrap. It was 293. So it's 48 remainder 5. Later on, did you learn maybe to write it as 48 and 5, 6? Do you remember this? The remainder goes over this. Remember, guys, if we wrote it like this, okay, it went in 48 times with 5 left over, so that leftover is 5, 6. Does that help you see that? Because when we do polynomial functions, we're going to want to write fractions, we're going to want to write it this way. To check the problem, does anybody remember? You would do 48 times 6 plus 5, and it should get back to 293. Everybody okay? Okay. So let's try one more. We'd go 22 into 38. 1 times 22 is 22. Subtract. Bring down. We need to stress that part. 22 into 162. If you look at the 2 here, you would think it goes into 16 maybe 8 times, but I don't think we're going to make it, right? So 7. So 14, 154. I hope that's right. Okay. Subtract 8. Bring down the 4. 22 goes in. What do you think? 3 times would be 66. Is going to be 18 maybe. Did I do that right? So we'd have 18 over 22, which would reduce. How would we, I don't care. How would we check this? Okay, 173 times 22 plus 18 should equal 3824. Oh, whatever I was trying to say. All right, so we're going to take those ideas over and do the warm-up sheet today. All right, so if you write big, you might be in trouble, but hopefully we can fit this on here. 3x cubed plus 10x squared minus 13x minus 20 is all being divided by 3x minus 5. All right, guys, the idea, in some ways, polynomial division is easier because there's no guessing how many times it goes in, you need to figure out exactly what will multiply to make it come out exactly the same. So what I'm saying is 3x needs to become exactly 3x cubed. So it needs to multiply by x squared. And then you are distributing x squared times both of these terms. So x squared times 3x should be 3x cubed. That was the point. But then you also have an x squared times a minus 5, which is a minus 5x squared. Then we're going to subtract. What's going to get, this is the step that kills everybody, yes? Why? They want to subtract here, and then they forget they're subtracting that term. So what I do when I do these is I go through and I change the signs because then I'm adding. Do you understand what I'm saying? Let me go back. What we want to do is subtract both of these terms. So I write that, and then I think, okay, I'm just going to add the opposite. So this is going to be 0. This should always drop out. But back here, you got to remember we're subtracting a negative, so we're adding a positive, and it turns out 15x squared. Got it or not? Need me to go back over that one, okay? Now, this is, again, the easier part. We don't have to guess. We know exactly. Okay, let's bring down first. My bad. But we know exactly what we want. We want 3x to become exactly 15x squared. So a positive 5x would make it exactly 15x squared. So then 5x times 3x is 15x squared. But 5x times negative 5 is what? Negative 25x. Okay. We're going to subtract all of that, which I'm going to think of as adding the opposite. So these should cancel out if we did it correctly. But remember, it was a negative 13 minus a negative 25, which became plus positive. So we have 12x. Everybody okay? Bring down minus 20. And I think Mr. Abruzzo might have written us one that comes out nice. Because what happens next is we need the 3x to become exactly 12x. So we're going to multiply by 4. When we distribute over there, we get 12x and a minus 20. So when we change that to subtract or add the opposite, it comes out even. Everybody okay? So if for fun we wanted to FOIL this back together, it should come out what we started with, right? 3x cubed plus 10x squared minus 13x minus 20. Obviously that fits right on the screen right there. Okay. So there's no remainder to worry about. So any questions on that one? I hope the next one doesn't come out nice because I wanted to practice writing it, but we'll see. Anybody want to try this one? How about if you all try it and then see how it goes? Oh, she's evil. What do we need? That, Miss Abruzzo. We need a placeholder. Does anybody see where we need a placeholder or why we need a placeholder? Yeah, we have an r cubed. We need standard forms. So we have an r cubed plus 7r squared, but there's no r term. Yep, so we're going to put 0r in there. Does anybody kind of remember that from doing this last year in Algebra 2?
We did it last year. We did it weirdly.
Okay. you should have done polynomial long division in your class, whether you had to write the placeholder in or not. All right. Is there somebody who's really struggling with this, who wants to help me talk through this? Okay. Can you help me with this one? Yeah. Just tell me. R times what would become R cubed? Okay. So what is going to happen when I multiply both of those? Ah, interesting. So when we subtract, both of those drop out. So yeah, we have 0R plus 10, which is just 10. Is anything times R going to become 10? If we multiplied by 0, you could do that. You could put a plus 0 up here if that helped you think of it. Multiply out, you'd get 0R plus 0. You'd subtract, and you'd have your 10, right? So if that helped you think of it. But the remainder is just 10. This is a weird question. That Abruzzo, she gives us tricky stuff. So the remainder is 10. I should not write that with an R, though, because there's R's in this question. All right, so how could we write it as a fraction? Let's do that. Yes. And what are we going to do? We need to be really careful because this is algebraic with variables in it. We need to put something in here. Plus, yes. Right? If your answer was 2 1/8, when you did it with numbers, straight up arithmetic, it's the same as 2 plus 1/8, right? We don't want this to say R squared times 10 over R plus 7. We need the plus in there. Does that make sense? All right. We're going to do a couple trickier ones for great fun. But let's learn synthetic first. Okay. That's horrifying. Should be doing long. Because you can only do, yes, but you can only do synthetic if this is in this form. Okay? Because we're going to do things where, and we're going to have to do things where you have things like this eventually. Okay? This is what we're going to do, if not next week, the following week, when we do rational functions. To find the end behavior this approaches, you're going to have to use long division. Okay? Because you can only do synthetic division if you have x plus or minus a constant term. All right. So we can on this one. It's an n, not an x. The thing students generally mess up is the 0 is what goes in this box over here. So what is the 0 associated with n minus 6? Positive 6, right? And if you set that equal to 0, okay, it is the 0 associated with that divisor. Does everybody get that? Okay. Across the top, you write the coefficients, and you have to put in placeholders if there's any missing terms in standard form. So this has a 1 n to the 4th, then what? Negative 6n cubed, 0 n squareds, negative 7n, and the constant term is positive 38. All right. The rules here are bring down the first one, and then it's multiply, add, multiply, add. Now the other one was multiply, subtract, but remember we already did the 0 thing here by making this a 0. It's easier to do it this way. You don't have to think about subtracting. Okay, so we bring down the 1, always the first term just drops down. Then we multiply 6 times 1. These numbers out here are what we're multiplying, okay? 6 times 1 is 6. Add down the column and we get, now this is where it usually goes wrong. What's 6 times 0? Okay. Add, yes. I even make mistakes on the easiest parts of this sometimes. 6 times 0 is 0 again. Add, -7. Multiply, 42. And add, is it 4? On a good day? Okay. Now, this is what's important that you understand. We got rid of all the variables and we did it with just numbers. We have to put them back in. What you need to know is the last term is the remainder. I love this term, I don't know why, but this is called the depressed polynomial. It's so sad it was divided into parts. I don't know why it's called the depressed polynomial. And to write the depressed polynomial out as a polynomial again, the last term is constant, and then you go up from that. So this would be the linear term, the quadratic term, etc. So for our purposes, we have a, let me switch colors quick. We have a -7 that's a constant. Then this would be an n squared, and an n cubed. So we ended up with n cubed minus 7 plus a remainder of -4 over n minus 6, because that was the divisor. Let's go over that vocabulary. I haven't used that vocabulary yet. Let me put a... Everybody okay? Got written down what you want there? I can go on? Anybody still writing? Patrick, you got it? Okay. So just use this for me, divided by 7. Just, anybody know the vocabulary? Divisor, dividend, quotient, any of those? When we do this, where's the quotient going to be? Yes, the quotient is going to be up here. The quotient is the answer, right? That's the only one we know? Yes, the divisor is what you're dividing by. Good call. And so then this is the dividend. Oh, that's a D. Yeah, don't, I'll write it over here again. All right, just to review the vocabulary. And then when you're done, let me see how fast I can do this. 4, 28, 36, 5, 35, 1. How did I do? Okay, when you're done, you write quotient plus remainder over what? Divisor. Okay? We'll be going over that again on Monday, probably. All right. So, who thinks they've got this synthetic business down? Go ahead. No, just tell me. It's fine. You want to do it on the board, Sam? Go ahead. Oh, are there more on the back, guys? Okay. Oh, it's just the answers? I do have some more practice, though. Yes. Okay, so we have an x cubed, an x squared, and an x, and there's no constant, so she put a 0. That seems grand. What happened here? I like that she wrote equals r, so she remembered that was just a remainder. Yes. What? Ariana, were you going to say something? Okay.
Oh, I did it right.
If wait a minute. If you think about this, if you have an x cubed over an x, if we left off all this and this, the answer should be an x squared, right? Did I do something? Do you see we started with an n to the 4th here and we divided out an n? That's why our answer had an n cubed. Better? Okay. This is what I want you to do, guys. I want to do 2 more questions. Everybody awake? Okay.
Did I do it right?
Yes, you did it right. Perfect. Anybody have a question on that one? All right. I want you to do an icky one by long division for me. Yeah, there's nothing on the back that's going to help you. Do you want to write? Can you write on the back? Can you just tip it sideways and do a question in the middle there? Okay. Let's do x cubed. This is the original question. X cubed minus 1 divided by x squared plus x minus 3. Okay. What are we going to do when we go to write it out? Where? Yes, I would a 0x squared and a 0x, and then I had a minus 1. Can you try that? See how it goes. Anybody have the next step? You subtracted. What did you end up with? Anyone at all? There's an x squared here, right? That's not a 0. So we have to, if we distribute this negative through here, we'd get a negative 1x squared plus 3x minus 1. Everybody okay? You can multiply by a negative 1. Good call. Which will be a negative 1x squared minus an x plus 3. What still happens? We're subtracting, which will change it to adding the opposite. What are you talking about? You need it to be exactly the same thing, because then you're going to change it and subtract it.
Oh, it has to be the same.
Yes. Better? Okay, so negative 1 times all that, and then we changed all the signs and added, which is really subtraction, but we're just trying to keep track of things. So we get 4x minus 4. All right. It's really messy. The answer would be that plus 4x minus 4 over x squared plus x minus 3. When we get to a purpose for this next week or the following week, when we actually have to do this to find the end behavior, the good news is we will get to throw away the remainder. Okay, so what we're going to talk about eventually is that the graph of this out on the far ends will approach this line, which is what happened here. Okay. All right. I think we're good for the recording. Everybody okay? If you want to practice this